Hello, student. In last class, we have discussed about the we have discussed about the simple harmonic motion. In that chapter, we have discussed about the various type of motion. Sorry, about various relation of velocity, acceleration at mean position and at extreme position. Now, uh, our next topic is differential equation of S.H.M. So, next topic is differential equation of S.H.M. Differential equation of S.H.M. We know that in S.H.M, the restoring force is proportional to displacement. So in S.H.M, restoring force is proportional to displacement. Restoring force is proportional to displacement. That means F is equal to minus of Kx. This is equation first. Negative sign shows that force and displacement are in opposite direction. Force and displacement are in opposite direction. Okay, by Newton's second law of motion, by Newton's second law of motion, F is equal to minus ma. Sorry, F is equal to ma. Newton's second law of motion states that force is directly proportional to rate of change of linear momentum. So F is equal to ma. Now, if we see that A is dB by dt, and V can be written as dx by dt. So d by dt into dx by dt. So which is equal to m d square x by dt square. So this was equation second. Now from equation first and second, minus kx is equal to m d square x by dt square, because they both have equal LHS, so they both have equal RHS. So d square x by dt square is equal to minus k by mx. Minus k by m is known as omega square. Sorry, k by m is known as omega square. So d square x by dt square is equal to minus of omega square into x. If omega square comes toward right hand side, then d square x by dt square plus omega square x is equal to 0 is the differential equation of S.H.M. Differential equation of S.H.M. Now, time period of S.H.M. Second is, there are two different things: time period of simple pendulum and time period in S.H.M. And one more thing is time period of second pendulum. Okay. Now, first thing is time period in S.H.M. Time period in S.H.M. So time period in S.H.M. is defined as time taken by the particle executing S.H.M. to complete one complete oscillation. That means if a particle is here at position A, B, O. If a particle do oscillation from A to B, then comes to B to A, this is known as its time period, means in which it complete one complete revolution. Okay, so that was known as the time period in S.H.M. So time taken by the particle executing S.H.M to complete one oscillation, one oscillation. So omega equal to 2 pi f. We know that omega equal to 2 pi f and frequency is 1 upon time period. So 2 pi into 1 upon t is known as omega. So omega equal to 2 pi upon t. Okay. So if you see, then t is equal to 2 pi upon omega. Okay. And the value of omega square is k upon m. So omega equal to under root k by m. That's why it's written as 2 pi under root m upon k. So the formula of time period of in S.H.M is 2 pi under root m upon k. Okay. Now next is time period of simple pendulum. Once a question came in your previous year, find what is simple pendulum and what is the time period of simple pendulum. Okay, we can do it in the form of question, the long answer type question. That what is simple pendulum? Derive an expression. Derive an expression for time period of simple pendulum. Time period of simple pendulum. Time period of simple pendulum. So what is simple pendulum? If a heavy point mass, if a heavy point mass is suspended by a massless and inextensible inextensible string with a rigid support, then such system is called simple pendulum. It's called simple pendulum. Or you can write it as a simple pendulum is obtained. A simple pendulum is obtained by suspending a small metal bob by suspending a small metal bob by a long and fine cotton thread through rigid support. Generally, this is a simple pendulum. If a bob is attached by a metal bob is attached by a small thread, then this is known as the simple pendulum. Now, expression for the simple pendulum, time period of simple pendulum, expression for time period of simple pendulum, time period of simple pendulum. So, suppose at any stand, suppose at any stand, during oscillation, during oscillation, the bob lies at position P. The bob lies at position P. At position P, when its displacement MP is equal to Y. When its displacement MP equal to Y, and the thread makes an angle theta, makes an angle theta with the vertical, with the vertical. Now, suppose this is the metal bob. This is its position M, and the length of metal bob is L. Okay. Now suppose at any position it is at point P. Bob is at point P. The angle between its position is now theta. So once its weights acting downward, which is known as mg, and the tension in the string applied as T. Now this mg can be resolved in two components. One is at mg cos theta, which is acting opposite to tension T, and one is mg sin theta. Okay, the displacement between them is y, mp equal to y. So there are two forces acting on a body. First is mg cos theta, which was balanced by T, and second one is mg sin theta, which was in a direction of the displacement. Okay, so the force acting on the bob are, the force is acting on the bob are weight mg of bob acting downward, weight mg of bob acting vertically downward, acting vertically downward, and second one is tension T along the string, tension T along the string. Now mg has two components. First is mg sin theta, second is mg cos theta. Now mg has two components, First one is mg sin theta, second one is mg cos theta balanced by T, which is balanced by T. Okay, so T balance mg cos theta. Now mg sin theta is the net force. Mg sin theta is the net force acting on the bob, acting on the bob, and tends to bring back to its mean position. To its mean position. So restoring forces F is equal to minus of mg sin theta, as because force is opposite to displacement, that's why I am taking the negative sign. And for the small angle, if the angle will be small, for small angles, sin theta is equal to theta. Now theta is equal to length of an arc upon radius, length of an arc upon radius. Now see in the diagram, what is the length of arc? Length of arc will be here y, and the radius will be L, because the length is acting as a radius. So length of an arc is y, mp will be a length, if mp will be a r, and the length of string will be L. So radius will be L and length of arc will be y. So theta is equal to y by L. So that's why I can put Fs minus mg in place of sin theta. I can put F is equal to minus of mg theta, and the value of theta will be y by L. So F is equal to minus mg y by L. We know that m into A is the value of force minus m into G y by L. M is cancelled by m. So A is equal to minus G y by L. And we know that the value of acceleration in the acceleration is minus omega square x is equal to minus G y by L. Now minus sign will be cancelled. So omega square is equal, sorry, omega square y. Here the displacement will be y now. So that's why we will take only y, omega square y. Y will cancel by y. So omega square is equal to G by L. Omega square is equal to G by L. So omega equal to under root G by L. The value of omega is 2 pi upon T is equal to under root G by L. So the value of T will be 1 upon 2 pi under root G by L. So that was the value of time period of simple pendulum. So G by L, huh? This was L. So T is equal to 2 pi under root G by L. So what it means that time period is depend on its length L and acceleration due to gravity G, but is independent of the mass of the ball. So time period of simple pendulum depend on its length L, depend on its length L, on its length L, and acceleration due to gravity G. Acceleration due to gravity G but is independent of the mass of the ball, independent of the mass of the ball, the mass of the ball, mass of the ball. Okay, that was your expression for time period of simple pendulum. Now next is second pendulum. A second pendulum is a pendulum which have time period of 2 seconds and its length will be approx 1 meter. Its length will be 99.9 centimeter or 1 meter. So the second pendulum is the pendulum in which the time period of a pendulum will be 2 seconds and the length will be 99.9 centimeter, or you can say it will be a 1 meter. Now I am the topic will be cleared from this chapter. Now dis I'm discussing question one by one of this chapter oscillation. Some question I have discussed in the previous class. Now some question is first question is can a simple pendulum can a simple pendulum be used in artificial satellites? Be used in artificial satellite? So answer will be no, because acceleration due to gravity is zero in the artificial satellite. Okay, if gravity will be zero And the so formula of time period of simple pendulum will be 2 pi under root L upon G. 2 pi under root G upon L. That's why their time period will be 0. So answer will be no. In an artificial satellite, in an artificial satellite, acceleration due to gravity, acceleration due to gravity is 0. Hence hence we cannot use simple pendulum, simple pendulum in an artificial satellite, in an artificial satellite. Now next question is, a girl is swinging, a girl is swinging, seated in a swing, seated in a swing. Just wait, huh? 1 upon 2 pi under root G by L. Omega square is equal to G by L. Acceleration due to gravity. Oh, something is wrong here. Just a minute, huh? Sorry, student. Here we have written something wrong because its time period will be, if you reciprocal both sides, then it will be 2 pi under root L by G. So 2 pi under root L by G will be the correct answer. The frequency will be 1 upon G. So here will also, you can write the time period will be L upon G. And if G will be 0, if G will be 0, then time period will be infinite. That's why we cannot use simple pendulum in artificial satellite. Now the next question is, a girl is swinging, seated in a swing. What is the effect on the frequency? What is the effect on a frequency? What is the effect on a frequency of oscillation in the stem? Frequency of oscillation if she stands. If she stands. Okay. Now we know that the time period of the simple pendulum is 2 pi under root L upon G. T is equal to 2 pi under root L upon G. Now frequency is 1 upon time period. So the value of frequency will be 1 upon 2 pi under root G by L, which means frequency is inversely proportional to length. Now if a girl is seated, so its length will be less. And now if she will be stand, then its length will increase. And if the length will increase, so the frequency of oscillation will decreases. Okay, that was the reason. Time period of simple pendulum is defined as 2 pi under root L upon G, and we know that frequency is 1 upon time period. So the value of frequency will be 1 upon 2 pi under root G by L. So what we conclude from here, that if both are constant, 2 pi and G will be constant, so frequency is the direct inversely proportional to length. Now, if a girl is seated, so its length will be less, and if girl will stand, so its length will increase. So if the length will increases, so the frequency of the oscillation will decreases. Okay, so a girl swinging in a swinging in a stand position, swinging in standing position, Location of center of mass. Location of center of mass or shifts upward, or you can simply say that length will increase upwards, or simply you can say that length will increases, and if length will increases, so frequency will decreases. So so length will increases, frequency will decrease. Frequency will decreases. Okay. Now next question is, next long answer question type question is, derive expression for derive expression for the kinetic energy and potential energy of a simple harmonic oscillator. Simple harmonic oscillator. I have derived this question earlier, the derivation of kinetic energy and potential energy of a simple pendulum. So in previous slides, we have described about the derivation of kinetic energy and potential energy. You can write same as it, that k is equal to half mv square, then v is equal to plus minus omega under root a square minus x square. Then we get the value half k a square minus x square. And now the kinetic energy will at extreme position will be zero, and at mean position it will be maximum. Now, secondly, we have derived the formula for potential energy. That potential energy is equal to half k x square. Uh, if you take the mod, then you will get the value half kx square. Okay. If you take the mod, then the mod of potential energy will be half kx square. At mean position, potential energy will be zero, and at extreme position, it will be half ka square. Now, next thing, the total mechanical energy will be the sum of kinetic energy and potential energy. That's why we have get total kinetic energy of half ka square. Okay. So only the question is asking about the kinetic energy and potential energy. So you have to write only the kinetic energy and the potential energy of the body. Okay, not as much. Now the next question is, obtain an equation for the frequency of oscillation for the frequency of an oscillation, frequency of an of oscillation of spring of force constant k, of force constant k, to which a mass m is attached, to which a mass m is attached. Mass m is attached. Now, the solution of this question is, suppose this was a spring, this is a fixed column, and that was the spring, and a mass m is attached to it. Okay, so the force will be downward. If it puts down, if it's displaces downward, so force will acting upwards. Okay, its displacement will be downward, so force will be in acting upwards. So force will directly proportional to its displacement. Force is equal to minus of kx. And we know that the value of force will be, according to Newton's second law of motion, the value of force will be Fma. According to Newton's second law of motion, Newton's second law of motion, F is equal to ma. Now that was equation second, and that was equation first. So from equation first and second, they both have equal LHS. Both are the value of force, so their RHS will be equal. So from equation first and second, from equation first and equation second, ma equal to minus kx. Okay, so a value will be minus k upon m times of x. Okay, so minus k upon m is equal to omega square. That's why omega square is equal to, hello, uh, 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 omega square is equal to k upon m. So omega square is equal to k upon m. Omega equal to under root k by m. So omega is equal to 2 pi upon 2 pi f is equal to under root k by m. So the value of frequency will be 1 upon 2 pi under root k by m. That was the value of frequency in S.H.M. Okay. Now the next question is derive simple. What is second pendulum? What is second pendulum? So second pendulum is a pendulum which have time period of 2 seconds and which have length of 99.9 meter. So a pendulum whose time period is 2 seconds and length approx 1 meter and length approx 1 meter is called simple pendulum. Is called simple pendulum. Time period equal to 2 seconds, length equal to 99.9 centimeter or approx 1 meter, approx 1 meter. So that was your second pendulum. Now the next question is, so your other questions are, all questions are ended. Escape velocity, Newton second law, motion, conduction, conduction. Question is define simple pendulum. Define simple harmonic motion. Define simple harmonic motion. Define simple harmonic motion. Simple harmonic motion. Harmonic motion. Show that the motion. Show that the motion of point projection of a particle. Point projection of a particle performing uniform motion. Performing uniform circular motion on any diameter is any diameter is simple harmonic. A simple harmonic. Now the first is define simple harmonic motion. So what is simple harmonic motion? I have described it earlier. That sorry, huh? Both question in this question the language is changes. Question is too much easy. So just wait. I have described this question earlier. Yes. Define simple harmonic motion. So simple harmonic motion, a particle is said to execute a simple harmonic motion if it moves to and fro about a main position under the action of a restoring force which is directly proportional to its displacement. We have described this question earlier. So you have to write this definition. And the second was this point projection. So in that, this is the derivation of a point projection. All this derivation, the derivation of y is equal to a sine omega t, the velocity is equal to a omega t under root 1 minus sine square omega t. Actually, the value of velocity will be this a omega t cos omega t, and the value of acceleration will be minus a sine omega t. All these are the derivation of the point projection. Okay, so you have to write this in the derivation of the point projection. Now, another question is, so, student, that's are your some important questions of previous year of harmonic motion. So this chapter will be ended. Now you can, if you have doubt in any other questions related to these, so you can give questions to the sir or ma'am that I will provide you solution of these questions. Okay. So that's all for today. And today we have ended our chapter simple harmonic motion. In next class, we will discuss a new chapter. Firstly, we will discuss the some important theorems or important derivation of that chapter. Then after that, I will solve some question for you. I will solve some previous year questions for of that questions. Okay. If you have any doubt, then you can consult. Then you can tell with the ma'am. So you can give me question. I will solve it. Solve on YouTube again. Okay. Thank you. That's all for today.